Good morning to all. We will wait for 5 minutes more, then we will start. Welcome you all to the additional tutorial of multivariable calculus. Myself, Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of factor geometry and dynamical systems. Today we will do some illustration based on continuity, differentiability of multivariable functions, And besides this, we also do some properties related to beta gamma functions and some illustration related to that. And after that, we will do some illustration on change of order of integration and change of variable. So let me write the first question here first. Question number one. We will start with one easy question of continuity, or you can say limit existence. Examine if the limit the following function exists at 0, 0, and the function is sine xy divided by. Examine this limit exists or not. Try it yourself. Then we'll discuss it here. Try this. So anyone remember that how we can show that limit of two variable function exists or non-existing criteria? Anyone? So in order to show that limit does not exist, we will take two curves along which the limiting value of the function is different. Then we can say that that limit of the function does not exist at that point. Rather, and we can also take some generalized curve, suppose y equal to mx or y equal to mx square, where m is a parameter, and if our limit is depending on that parameter, then we can say that the limit does not exist. And in order to show the existence of the limit, we have to show that epsilon delta definition holds for that function. So we will start here along with two curves. First of all, along x-axis. So what is along x-axis? Y equal to 0. So f x comma 0 will be sine x into 0 divided by x square 0 square, which is nothing but 0. Now limit xy tending to 0, 0 fxy is reduced to x comma 0, which is 0. Now we will consider some different curve, that is goes along y equal to x. So along y equal to x, the function will become fx comma x sine of x square divided by x square plus x square, which is equal to sine of x square divided by 2x. Okay. Therefore, this limit will be reduced to limit x tending to 0 sine x square divided by 2x square, which will be equal to 1 by 2 x tending to 0 sine x square, and we know that sine t by t as limit tends to 0 is nothing but tends to 1. That means this limit will be 1. So now you can clearly observe that when you move along y-axis, our limit is 0. While when we move along y equal to x, our limit is 2. So limit is different. It is not equal to 0. So what we can say that limit xy tending to 0, 0 fxy does not exist. So what is the general form of curve that we can take here? We can take along y equal to mx. So let me mention it here. This is some another, or you can say general curve approach. So if we take y equal to mx, then our function will become x comma mx sine x into mx divided by x square plus mx whole square, which will be sine mx square divided by x square into 1 plus m square. Okay, so this will give us fxy limit x tending to 0 sine mx square 1 plus m square, limit x tending to 0 sine mx square. So in numerator and denominator we have x square, but in the angle we have mx square. So we have to make the same at the denominator. So we will multiply and divide by m. Again, we know that the value of this particular limit is 1. So our conclusion of limit will be m by 1 plus m square. That is dependent on the parameter m. Therefore, we can also say here with this approach also that fxy does not exist. Okay. If anybody has any doubt, then you can stop me so that I can explain you. So till then, I'm writing the next question. Number 2. Examine the continuity of the following function fxy sine x square minus y divided by mod x plus mod y if xy is non-zero and 0 if xy is 0, 0. So we have to check the continuity of this following function of two variables, and the function is taken into two parts. One is the case when xy is non-zero, and when xy is 0, 0, then our function is 0. So any suggestion then what how can we approach this particular one? Anyone? Just give me a second. So any suggestion? See, as I told you earlier, that in order to prove that our function is continuous, we have to apply the epsilon delta definition. For that, here I would like to first write what is the recall that epsilon delta definition for a function of two variables. Mm, limit xy tending to some x naught y naught fxy is L. So we say that this is true if for every epsilon greater than 0, there exists a delta 0 such that this fxy minus L is less than epsilon whenever x minus x naught whole square plus y minus y naught whole square is less than delta. Or one more thing we have to emphasize here, that our this will be simply greater than 0. Or on the behalf of this, we may also write whenever our neighborhood of this xy will be like this. So this is the method to show the existence of the limit of a function of two variables at some point x naught comma y naught. Now here we need to discuss the continuity. So for continuity, we have to check the three things. First of all, we need to check limit of that function at x naught y naught. This is exists. Then second thing, that f x naught y naught is defined, or you can say well defined. And the last thing is that limit xy x naught y naught fxy, this is nothing but exactly okay. So in this particular question, we need to first check our limit exists or not. Before that, clearly we can guarantee that when xy is non-zero, our function is a division of two continuous functions. So we can say that our function is continuous for xy non-zero. Now we just need to check at 0, 0 since the function is breaking into two parts. So to check the continuity of this at 0, 0, First of all, we need to show that the limit of the function, particular function, exists. So to guess the limit, what we will do, we will take some curve along which we first decide what could be the limit. For example, along x-axis. Along x-axis y is 0. So fxy is 0. It means sine square. It was x minus y. So it will be x minus 0 divided by mod x plus mod 0, which is nothing but sine square x divided by mod x. Now limit xy tending to 0, 0, f of x comma 0 is should be x comma y. Then it will reduce to x tends to 0 sine square x divided by mod x, which can be multiply and divide by mod x, and it will become sine square x divided by x square into some mod x. Now we know that both of the limit exist, so we can break it like this: sine x square x divided by x square into limit x tending to 0 mod x. So this will give us 0, and since it is a continuous function, so it will be, sorry, this will give us 1, and this is a continuous function, so it will give us 0, that is 0. So we have a guess that we have a limit should be 0. So to show that, we will use the silent delta definition, and in a silent delta definition we need to show that fxy minus l less than epsilon for some neighborhood of this xy. Okay, so we will start with consider this fxy minus L, and here our fxy is sine square x minus y divided by mod x plus mod y minus 0. So this will be sine square x minus y divided by mod x plus mod y. So here I can remove mod because both the quantities are non-negative. So we know that sine x is mod of sine x, in fact, is less than equal to mod x, or just a second, less than equal to x. Okay, we know this thing that sine x is less than equal to mod of sine x is less than equal to x. So for that we need to write it here, mod of x plus mod of y. So for this particular one we can see like this: our sine function is like this, and our is like this. So we can say that this particular one, that sine x is nothing but less than equal to x. And if you will talk about that since here it is a neighborhood of 0, so we can directly replace that sine of x minus y with x minus y. So this can also be written as mod of x minus y and mod of x minus y divided by mod of x plus mod of y. And we know that by triangle inequality, mod of x minus y is nothing but mod of x plus mod of y, which will imply that mod of x minus y divided by mod of x plus mod of y will be less than equal to 1. And this quantity can be broken into this one particular one, and this one will be less than equal to 1. So I have replaced both of them. I have applied triangle equality twice, you can see that. So by the definition of epsilon delta, what we can say that our we have reached to this point because our x naught and y naught is nothing but 0. So mod x less than delta and mod y less than delta. We know that. So we know that mod x less than delta and mod y is less than delta. So it will be delta plus delta, which will be 2 delta. Okay. Now what we have to take, delta should be epsilon by 2. If we take delta should be epsilon by 2, then f of x minus 0 is less than epsilon whenever mod of x less than delta as well as mod of y less than delta, and these both are strictly greater than 0. So we show that limit of the particular function at 0, 0 exists and it is nothing but 0. Now what is the next task? To check f00 is well defined or existing. So f00 is nothing but 0. We have given here 0. So that means our f00 is also existing. Now clearly limit xy 0, 0 f, this is 0 and which is equal to f00. So what we can say, hence f is continuous on whole R square, like we can first write on not on, at 0, 0, in fact on whole R square. Okay, so we have to check the continuity of this function. So it is continuous at 0, 0, in fact on whole R square it is also continuous. Okay, now the next question is related to the differentiability. Discuss the differentiability of the following function. Okay, and the function is fxy is x times sin x, sin 1 by x, y times sin 1 by y, and this is true if xy is non-zero, and the other one thing is 0 if xy is 0. So we have to check the differentiability of this following question. So let me first recall the exact, or you can say precise definition of differentiability that we used to check it. So to discuss the exact definition of differentiability, just a second please, we need to show that limit limit delta rho tending to 0, 0 del z minus dz divided by del rho must be 0, and where del z is nothing but f of x plus delta z, sorry, delta x, y plus delta y minus this particular point, or you can say change in particular point, and our dz is nothing but partial derivative of f with respect to x at x naught y naught into this delta x or dx, you can say, plus fy x naught y naught is dy. So here we can also write delta y, since above we in the above line we have used this one. So, and delta rho is here nothing but under root of delta x square plus delta y square. Okay. So we need to show that this first of all we have to calculate this partial derivative at the point 0, 0. Why I am saying 0, 0? Because the differentiability is only breaking or only disturbing at 0, 0 because the function is breaking into two parts. In the above part, when xy is non-zero, if a product of xy is non-zero, then our function is a multiplication and addition of two continuous functions. Or you can say by the algebra of differentiability, so we can say that our function is differentiable for xy non-zero. Multiplication of xy is non-zero. But when the product of xy is zero or non-zero, the function is breaking into two parts, these particular two parts. So we have to first of all calculate this partial derivative at 0, 0 with respect to both the variables. Then we have to show that this limit goes to 0. So I'm giving you 2 minutes time to check this. Right. First calculate this partial derivative at 0, 0, at x, at y also. Then find out this dz and then calculate the change in z. Then should try to show that this limit goes to 0 or not. If it goes to 0, then our function is differentiable. Otherwise, our function is not differentiable. Try this one. Let me sort of correct this one. We say that f is differentiable at x naught y naught if this particular limit 0. So let us start with computing f partial derivative of f with respect to x at 0, 0. Since our function is breaking, so we will apply the limiting definition to calculate it. It is 0 plus h comma 0 minus f of 0, 0 divided by h. Now tell me which definition we should apply. I mean, there are two parts of function that category falls into which part. See, here if the product of x, y is 0, then we say that our function is nothing but 0. So observe from here 0 plus h into 0 is 0. So our function will be 0 minus again 0 divided by h, which is nothing but 0. In a similar way, if you will try to calculate this partial derivative with respect to y, so it will be 0, 0 plus k, 0, 0 divided by k, limit k tending to 0. Again, the product is 0, so the functional value will be 0 minus 0 and divided by k is 0. So from this, we can say that our dz is 0 into delta x plus 0 into delta y will be 0. Now, what is our delta z? Our delta z is 0 plus delta x comma 0 plus delta y minus f at 0, 0. Now, since the product of these two is non-zero, then our functional value will apply of this case, particular case. So this will give us nothing but delta x into sine 1 by delta x plus delta y into sine 1 by delta y. And since this product is 0, then functional value will be 0. So now what we have to show, that the limit del rho tends to 0 of this del z minus dz divided by this del rho should be 0. Del rho tends to 0 of delta x sine 1 by delta x plus delta y sine 1 by delta y divided by del rho. We need to show that this is 0. So to show that this limit exists or not, what we can do, we can go along this x-axis. Now we can before that we can first treat this is as a some single variable. Sorry, not single variable. We can replace delta x by some h or delta y some y. Okay, h sine 1 by h plus k sine 1 by k. Just I am rewriting it as, and this will be h square plus k square. So this h square plus k square will tends to 0. So this is our function. So now we will choose along y-axis. Along y-axis is what? X is 0. That means here, since we are using h, so here h will be 0. This will give us limit k tending to 0, k sine 1 by k divided by k, and this k and k cancel out, and we know that limit k tends to 0 sine 1 by k does not exist. So if along one path it is not existing, that means this whole limit is not existing. So we can say that our function, since it is not going to 0, hence we can conclude that f is not differentiable, particularly at 0, 0. Differentiable when f is not differentiable for those points for which this function is breaking. So we can directly say f is not differentiable. Okay. So I'm again saying, if you have some doubt, you can stop me and ask me. Till then, I'm moving to the next question. Now, check the differentiability of fxy is equal to minus 2y to the power 4 x square plus y square if x square plus y square is non-zero and 0. So this will nothing but xy 0, 0, because The square addition of the squares is zero, is can be zero if and only if both of them are zero. So we have to check the differentiability of this particular function. So again, this function is given into two parts, and we know that this is a division of two differentiable function whenever xy is non-zero. Thus, we can say that our function is differentiable for all xy non-zero. And when xy is 0, 0, then our function is breaking into two parts. So we have to check the differentiability at particularly at 0, 0. So again, to check the differentiability, we need to first calculate its partial derivative at 0, 0. After that, sorry, we will check this limit, whether the limit is going to 0 or not. If it goes to 0, then our function is differentiable. If it does not goes to 0, then our function is not differentiable. So let me change this color because it is a solution, not the definition. Now let's talk about particularly this one. So we first calculate here partial derivative of f(x) at 0, 0. Since function is breaking at 0, 0, then we will apply the limiting definition, which is 0 plus h comma 0 minus f of 0, 0 divided by limit into 0, 0 plus h to the power 6 minus 2 times of 6 to the power 4, 0 plus h whole square, 0 square minus 0. So this will give us limit h tending to 0, h to the power 6 divided by h cube, which is nothing but 0, because I am writing one more line, limit h tending to 0, h cube, this is 0. Next one is fy at 0, 0. So this will give us k tending to 0, 0 comma 0 plus k minus f of 0, 0 divided by this k. So to check this, limit k tending to 0, our given function is 0 to the power 6, 0 plus k to the power 4 divided by 0 square, 0 plus k square minus 0 divided by k. So this will give us limit k tending to 0 minus 2k to the power 4 divided by k cube, which is limit k tending to 0 minus 2k is 0. So we got our partial derivative again at 0, 0 is 0. So our dz will be nothing but fx at 0, 0 into delta x, fy at 0, 0 into delta y, which is 0. Now what is delta z? 0 plus delta x, 0 plus delta y minus f at 0, 0, which will give us delta x to the power 6 minus 2 times delta y to the power 4 divided by del x square plus del y square. Okay. Now what we have to check? We have to check that limit delta rho tending to 0, this delta z minus dz divided by this delta rho, this whether this limit is going to 0 or not. Consider this particular one. This will be limit delta rho tends to 0. Delta x to the power 6 minus 2 times delta y to the power 4 divided by delta rho into delta x square delta y square. So since we need to check this limit, so we can also use here polar coordinate. So delta x r cos theta delta y r sin theta. So this will give us delta x square plus delta y square is nothing but r square. And we know that delta rho is also the same. So this delta rho will be r square. Delta rho square will be r square. And this limiting value will say that limit r tends to 0, r to the power 6 cos theta to the power 6 minus 2 times r to the power 4 sine 4 theta divided by this is r and this is r square. So this will give us limit r tending to 0. We can take out r to the power 4. We will left with 1 r here. R square cos to the power 6 theta minus 2 times. Okay. So since it's a multiplication of r, so this will give us 0. So we got our limit is 0. Then we can say that hence fxy is differentiable on rule R. Okay, so now we know in a better way that how to check the differentiability. Therefore, let me move to the some other type of questions. Particular one, I would say. Let me give you the glimpse of absolute minima or absolute maxima. Question number 6, I think there is a mistake of counting. Okay, this one is 3, and this would be our fourth one, and this will be our fifth. So find out the absolute minima and absolute maxima of fxy is equal to xy. Okay, and our on the line segment x is equal to 2t and y is equal to t plus 1, where t is minus 1 to 0. Let me rewrite this minus 1 to 0. So we have given a line segment, or you can say parameterized form of this particular line segment, and we need to find out absolute minima and absolute maxima of this particular function on this line segment. So how we can approach this particular one? Anyone? So there can be two approaches. Since it's a function of two variables, so we can follow the approach of that partial derivatives, and then we will find out its critical point. Then we will check that the critical points corresponds to a local minima, local maxima, or saddle point, or the test is inconclusive for that particular critical point. Then we can check this equation of line as a boundary, and then we can find out, or we can decide what is the absolute maxima or absolute minima. And the other approach is that we can substitute the value of this x, since it is an easy value, so we can substitute this value of x and y in this particular function as a variable of t, or as a parameter t. So our function will reduce to a single variable. So let me first draw the line. X is equal to 2t, y is equal to t plus 1. So we can write it as y is x by 2 plus 1. We can say that x by minus 2, y by 1 is 1. So this will be 0 comma 1 and this will be minus 2 comma 0. So we need to check at this particular line segment. So to check that, we will substitute the value of this fxy, and this will give us 2t into t plus 1, which will be equal to some 2t square plus t. And let this function, for the simplicity, we are just writing with some another function, which is 2t square plus 2t. Now what we have to do, since it's a single function of single variable, then again we have to think about its critical point, and we have to apply the second derivative test to check its local minima or local maxima. So single derivative will be 4t plus 2. Okay. Now put this g dash t to be 0, which will give us 4t plus 2 is 0. And this will give us t is equal to minus half. So the critical point of our function g. Now g double dash of t, since we need to apply the second derivative test, so g double dash t is 4. So g double dash at minus half will be also 4, which is greater than 0, and therefore this my second derivative test t equal to minus half corresponds to a local minima point for g. So we have one point that equal to minus half, and the other 2 points are this minus 1 and 0, that is the boundary point. So we need to check what are the points. T is 0. In fact, I would write t is minus 1, t is 0, and our critical point is t is half. So function value, yani, that means here gt. So since our ft is converted into gt, so the absolute minima or maxima of this gt is the same as absolute minima or maxima of fx. So here it will give us, since our function is 2t square plus 2t, so it will be 2 times of minus 1 square plus 2 times of minus 1. So this will give us 2 minus 2, that is 0. Similarly, 2 times of 0 square, 2 times of 0 will be 0. Now 2 times of minus half square plus 2 times of minus half. So this will give us 1 by 2 minus 1, which is minus half. So absolute maxima of this particular fxy, absolute maximum value is nothing but 0, and on particular given line segment we are talking about. So it can be more than that on other particular line segment or less than that. So on this particular line, this is the absolute maxima value and absolute minimum value. So now we have a glimpse of how to deal with this particular type of absolute minima maxima type question by second derivative test. So either we can convert our function into single variable if it is easy, or the other one is to apply a second derivative test of this function of two variables. Now, then in the next question, we can have a glimpse of change of variables, or how can we deal after changing the variables, and how can we calculate that particular multiple integral. So change into cylindrical coordinate and calculate, and this is a triple integration. So our first value is this, another one is this, x square plus y square to sum 2 z square dz d dx and dy. Okay, so we have given this triple integral and we need to calculate the value of this triple integral after changing our coordinate Cartesian coordinate system to cylindrical coordinate. So let me first mention what are the cylindrical coordinate, then you will first try yourself. Cylindrical coordinate system. What are cylindrical coordinate system? X is r cos theta, y is r sin theta, and z will be same as z. Now theta here 0 to 2. So this is our cylindrical coordinate system. We need to convert our triple integral into this cylindrical coordinate. Then we will calculate the value of this particular integral. So try this. Try this one. So in order to change this into this cylindrical coordinate system, we know that we have to calculate the Jacobian of this, and Jacobian is xyz divided by r theta z. So we need to partially derivate with respect x or with respect to r theta and z. So this will be cos theta minus r sin theta 0, sin theta r cos theta and 0, and this will be 0 0 1. And what is the formula of this? I am writing it here: x with respect to r, x with respect to theta, x with respect to z. Similarly, y with respect to r, y with respect to theta, y with respect to z, z with respect to r, z with respect to theta. Okay, so then we will expand along this row, oh sorry, this column. So our first is entry 0, this entry is 0, so the left will be only this cos theta minus r sin theta r cos theta. So this will give us r cos square theta plus sine square theta. This will give us r. So our Jacobian is r. Now we need to decide the limits. And from this, what we can say that x square plus y square is nothing but r square. So we can replace this quantity with r square. So we can draw this particular one region. Our z is varying from r square to this 2, and to draw this particular region, we can simply see that x is varying from 0 to under root 1 minus y square. That is, x is nothing but it is a circle centered at 0, 0 with radius 1, and y is vary from 0 to 1, although both of them are positive. So this will be first quadrant. This will be our first quadrant, and therefore our x will vary, our radius will vary from 0 to 1. So we have to take this radial strip, and our r will vary from 0 to 1, and our theta will vary from 0 to, and this is theta equal to 0, and this will be theta equal to pi by 2. So this will be pi by 2. So now we have decided our limit, what will could be our limits, and z will remain as z. So our triple integral, that is 0 to 1, 0 to 1 minus y square, and x square plus y square to 2 z square dz dx dy. This will become 0 to pi by 2, 0 to 1 r square to 2 z square r dz dr d theta. Okay, so this will be 0 to pi by 2, 0 to 1 r. So we will left with r square to 2 z square dz and dr d theta, which will be 0 to pi by 2, 0 to 1 z cube divided by 3 r square to 2 dr d theta to 1. This will give us 1 by 3 can take out. This will be 2 cube minus r square cube dr d theta. So this will be 1 by 3, 0 to pi by 2, 0 to 1, 8r minus r to the power 7 dr d theta. So this will be 1 by 3, 0 to pi by 2, 8 r square by 2 minus r to the power 8 by 8, 0 to 1 d theta, which will give us 1 by 3, 0 to pi by 2. This will be 4 minus 1 by 8 minus 0 d theta. So this will be 1 by 3 into 31 by 8. And the left integration will be 0 to pi by 2 d theta, and this will be 31 by 24 theta 0 to pi by 2, and which will give us 31 pi by 48. Okay, so this is our integration of this triple integral after changing into cylindrical coordinates, or you can say that directly in triple integral value is 31 pi by 48. This is also a question of I think week 5 assignment, last question number 10. So the answer is 31 pi by 48. So the next question includes why we need change of order of integration, or change of order of integration matters in case of while we are integrating our function. So I think this one is, if I don't know why I'm doing this, 6, then this is 7. So consider I1 is equal to 0 to 1 dx, 0 to 1 dy, or you can say x minus y divided by x plus y cube dy, and I2 is 0 to 1 dy, 0 to 1 x minus y, x plus y cube dx. So we need to calculate these two integral and also check I1 is equal to I2. This statement is true or false. We need to check this. So for that, you can clearly see that this is a glimpse of change of order of integration. So this is, if I would rewrite it, this is nothing but 0 to 1, 0 to 1, x minus y by x plus y cube dy dx. And this is 0 to 1, 0 to 1, x minus y by x plus y cube dx dy. So if these two integration values are equal, then we can say that order of integration of in this particular integral does not matter. And we have to justify that why it is happening. So now, if it is not equal, then we can say that order of change of integration matters in case of in a double integral, or we are when we are integrating our double integral. So try this one first, then we will discuss it here. So anyone got any conclusion for this? So let's do it here. 0 to 1 dx, 0 to 1 x minus y, x plus y cube dy. Since in denominator we have x plus y cube, so we can make in the numerator also x plus y type thing. So it will be x plus x and minus x, x plus y cube dy. So this will be 0 to 1 dx, 0 to 1 2x divided by x plus y cube minus this will be x plus y divided by x plus y cube dy. So this will be our integral now, which can be also written as 0 to 1 dx, 0 to 1 2x divided by x plus y cube dy, and minus 0 to 1 by x plus y square dy. So this will be our integral now. So this 0 to 1 dx. Now we are integrating with respect to y. So we will treat x as constant. So this integral value will be 2x. And we know that y to the power n is nothing but y to the power n plus 1 divided by n plus 1 when n is not equal to minus 1. So since here n is 3, so we can write it as x plus y to the power 2 into minus 2. The minus 3 plus 1 is minus 2. So we will put the value 0 to 1. So similarly, this will give us minus 1 by x plus y at 0, 1. Okay, this will be 0 to 1 dx. This is when we put y value, we are putting value of y. So this will be 2 over 2 cancel out, and this will be minus 2x divided by x square. In fact, x plus 1 whole square. Okay, minus minus will be plus. So at 0, this will be 2x by minus x square. And the other factor is minus 1 by x plus 1. And that 0 will be minus minus plus 1 by x. So we will get this value 0 to 1 dx minus 2x by x plus 1 whole square plus 2 by x plus 1 by x plus 1 minus 1 by x. We will get this value for the first part of this integration. Now we have to integrate with respect to x also. Before that, we can a little simplify it in the form 0 to 1, or you can say directly we can integrate. Here in the denominator, we have x plus 1 whole square, and in the above, we have 2x. So what we can do here, we need some kind of numerator, like which is a differentiation of this particular denominator, and the differentiation of this denominator is 2 times of x plus 1. So we can write it as 2 times of x plus 1, x plus 1 whole square. I'm separating also, plus this 2x minus 1 by x will be 0 to 1 dx by x. And the other factor is, since we have added here plus 2, there will be minus 2. So since it is a minus sign, so this will be 3 times of 0 to 1 dx by ln x plus 1, which will give us value minus ln, in fact not ln, minus 1 by x plus 1, and 1 minus sign is outside, 0 to 1. This will be ln mod x 0 to 1, and this will be 3 times ln mod of x plus 1 0 to 1. Now tell me whether we have done any kind of error or this is the correct, because ln 0 is minus infinity. So from that, can we conclude something, or we have to check it again that whether we have made some error or we are doing correct? Check it. See here, we have integrated without saying, and I have done this to make a realization that our integration will become maybe easier if we simplify this before integrating. So what we can check first, we can check that this particular value may be simplified in very simple form. So for that, let us take that. What will be the LCM of this? Tell me what will be the LCM of this? X plus 1 whole square into some x. So this will be minus 2x square because here x also, and this 2x 2 plus x minus 1 by x can be considered 1 by x, so it will be plus x plus 1 whole square into x, or no, there will be no x because in the denominator there is x. Now the other part is x into x plus 1. So what this is giving, this is giving minus 2x square, x square plus 1 plus 2x, and plus x square plus x divided by x plus 1 whole square by x. So from here we will get, this is x square, and this cancel out. This will be some 3x plus 1 type thing. This one. So from here we can also uh, solve in that way. You can rewrite it as x plus 2x plus 1 divided by x plus 1 whole square. From this, we can say that this will be 1 by x plus 1 whole square, 2x plus 1 divided by x into x plus 1 whole square. So from here, we can do in such a way that we can get some integral kind of thing in that scenario. Or rather, we can also check this problem, well-defined of this problem. So here I think there would be some error because it is not that much easy. You can say if you will simplify this factor. So let me just rewrite it. Just a second, please. So here we have made our errors. Here we have cancelled this 2 and still we are writing here 2. So I think we have to be more careful while doing this kind of integration, and uh, let me again solve it with the zero error. The second approach I have told you sometimes that we did not simplify our integration, and there will be a possibility that we have not solved it earlier. The best way is to do not get into the next step until you have solved the previous step in a shortcut way. So When we will put 1 here, this will give us, so this will give us minus x divided by x plus 1 whole square, and minus minus will get plus x by x square. This will be first value minus, when we will put 1, minus 1 by x plus 1 plus 1 by x. So which will give us very simply, this is minus x by x plus 1 whole square plus 1 by x, minus minus will plus 1 by x plus 1 minus 1 by x. So this will cancel out. So we have made that mistake, and because of that, that integration will become very tough. So this is a good learning for us, that we have to look at our integral first, so that it might be simplified in a very simpler way. Okay. So is there any other mistake? So from here we have taken x plus x minus x, and this will give us 2x divided by this, and this will give us x plus y to the power minus 3 plus 1 divided by minus 3 plus 1, which will give us this 1 by x plus y square into minus 2. Similarly, here we will get minus 1 and divide by minus 1. So when we putting 1, it will minus 1 by x, and this will be 1 by x. And this will be x by x plus 1 whole square, and this will be with positive sign x plus 1 by x. So this will be 1 minus x, or in fact, this is minus x, and we can take LCM x plus 1 whole square. So this will be x plus 1 dx, which will be nothing but 0 to 1 dx by x plus 1 whole square, which is really quite easy to solve. This will be nothing but 0 to 1. So minus half minus 0, in fact plus 0 to minus half. Okay. The learning from this mistake is that we have to solve that integration very carefully. So now if we will change the order of integration 0 to 1, this is dy this time second, and here it is maybe looking first, but it should be second. So this will be x minus y divided by x plus y cube dx. So with respect to integrating dx, we need to here make x plus y minus y. So it will be like this dx. So this will give us 0 to 1 dy 0 to 1 1 by x plus y cube, and separating these two integral minus 2y divided by x plus y cube dx 0 to 1. So this will be our two integrals. Now again 0 to 1 dy. So this will give us minus 1 by 2 times x plus y square. So this will be again square. So this will be minus 1 by x plus y, 0 to 1. And this will give us, we are treating y as constant. So this will be x plus y whole square, 0 to 1, 0 to 1 dy. So this will give 1 by 1 plus y minus minus will get plus. So we are putting the value of x, so it will be in terms of y, 1 by y minus, when we put x is equal to 1 here, 2 and 2 will first of all cancel out, or you can make it as minus minus plus. So this will give us y divided by y square. So y divided by 1 plus y square minus 1 by y. So from here we can conclude that this will cancel out, and again these two, addition of these two after taking the 1 plus y whole square, it will be nothing but 1 plus y whole square. So this will give us minus 1 by 1 plus y, 0 to 1. So what will be this answer? Or this will give us 1 plus y whole square minus 1 minus y plus y. So this will be minus with the negative sign. Negative sign. So this will become positive. This will give us 1 by 2. So clearly you can observe that I1 is half, I2 is I1 is minus half, I2 is half. Clearly I1 not equal to I2. So the given statement is false. So that means while integrating double integral, that the order of the integration definitely matters. So with this, we have had a glimpse to how to solve that, how to discuss this change of integration, how this change of integration matter in these two variables, or you can say multivariable. Now the next question is, or you can say calculate here, calculate the value of the following integrals. So we have two parts. In the first part, we need to calculate 0 to infinity x to the power c divided by c to the power x dx. In the second one, we need to calculate 0 to pi by 2 under root tan theta d theta. And in the c part, 0 to pi by 2 under root cot theta d theta. So we need to calculate this integral. So anybody is getting any feeling that how this first integral looking like? Is there any some standard form, or we can just
Beta gamma function.
beta gamma function? Okay. So we have to change into that form of beta function, or we can say gamma function. We have to see in which we will be, it will be easy. So for that, uh, see, we can rewrite it as dx. And first of all, let me recall gamma of some m is nothing but 0 to infinity x to the power m minus 1 e to the power minus x dx. Okay. So it should be look like this, e to the power minus x type of form. So this is 0 to infinity. You can write it as x to the power c, and this is c to the power minus x dx. Now we can write it as 0 to infinity x to the power c e to the power ln something e to the power minus. And write in this way because e and ln will can again give us c to the power minus x. Composition of e and ln. Then 0 to infinity x to the power c e to the power minus x times ln c dx. So here we need some e to the power minus x type sum, but if we have x times ln c. So what we will do here, we will substitute, and in the higher order integrals or multivariable calculus, we will call it as change of variables. So we are changing the variable x, ln c is nothing but t. So from here, dx will be 1 by ln c dt. Okay, and sorry, when this x is 0, then t is 0. And when x is infinity, then t is infinity. I'm doing this because we have to take care of limit also. So our integral was 0 to infinity x to the power c divided by c to the power x dx. It will be transformed to 0 to infinity t by ln c to the power c e to the power minus t and dt divided by ln c. So this will give us 1 by ln c to the power c plus 1, 0 to infinity t to the power c e to the power minus t dt. Now whether it is looking like this gamma function or not, to look like in this gamma function, here should be m minus 1 type terms, and here is c. So what we can do is we can write it as 0 to infinity t to the power c plus 1 minus 1 minus. Now it is same as the definition of gamma function. So from here we can conclude that this will be c plus 1 divided by ln c. Here our c was greater than 0. So therefore, we cannot further solve it, and this will be our final value of this particular integral. Okay. So in the next part, we need to calculate 0 to pi by 2 under root tan theta d theta. Now tell me what we can use here, how we can calculate its values, because it is not that normal integration. It is a kind of improper integral because tan theta will, first of all, integrating tan theta is um, difficult task in itself. Further, we need to calculate its value at pi by 2, and this will give us infinity. So let me recall the definition of this particular beta function in the form of that polar form. Let me write it here formally. We know that our beta xy is 0 to pi by 2, 2 times of sine to the power 2m minus 1 theta and into cos to the power 2n minus 1 theta d theta. Sorry, since I'm using mn here, so I will write mn. Okay, so we have to take the help of this beta function to get our this integration to be transformed into the some simplest form. Then we might use some beta gamma relation or some other things. So first of all, let us transform into this particular type of integration. So for that, we can just rewrite it as 0 to pi by 2 sine theta to the power half cos theta to the power minus half. We can rewrite it like this. Now this will be 0 to pi by 2. We can divide and multiply by 2. Now we have to write in this type of form 2m minus 1. So what we can write, 2 times of 3 by 4 minus 1. Okay. In the similar way, we can, here is theta, and cos of 2 times of minus 1 by 4 we can write it here, or simply 1 by 4. Simply 1 by 4 will work out. 1 by 4, this will give us 1 by 2, and minus 1 is minus half. So this will d theta. Okay. So by the definition of this beta function, we can see that half of this is nothing but gamma of, sorry, beta of 3 by 4 comma 1 by 4. This we have to calculate now. So since it takes the form of beta function, we can say that our beta function, beta of mn is nothing but m, gamma of m, gamma of n divided by gamma of m plus n. So we can use this relation. This will give us half of gamma of 3 by 4, gamma of 1 by 4 divided by 3 plus 1 by 4, that is gamma of 1, and gamma of 1 is nothing but 1. So we left with 3 by 4, gamma of 1 by 4. Now we also know that gamma of m, gamma of 1 minus m is nothing but pi by sine m pi. So using this relation, we can say that this will be half of pi by sine pi by 4. So what this will give? Pi by under root 2. In fact, 2 under root. So I hope this is clear. Now, in a similar way, try this third part, 0 to pi by 2 under root cot theta d theta. Try this one. Let me correct one thing here, that sine pi by 4 is 1 by under root 2. So this will give us pi by under root. Now you can try the other one part. Try this one, under root cot theta. This will be, this can be approached in a similar way as we have done earlier. So what we can write it as 0 to, yes,
It is the same as the above integral.
yeah, but okay, let me,
Since beta m comma n equal to beta n comma n.
so let me write it. In the above integral, we have that cos theta to the power half, and here we have cos theta to the power minus half in the above integral, here cos theta to the power plus half. So a little change in the writing pattern, but the answer can be the same. How? Let me do it here. This will be cos 3 by 4 minus 1 theta and sine 2 times 1 by 4 minus 1 theta d theta. This will give us 2 times of beta of 1 by 4 comma 3 by 4. I'm writing 1 by 4 comma 3 by 4 is because we have sine to the power 2m minus 1 theta. So beta of mn is nothing but beta of mn is same as beta of nm. Therefore, this will be nothing but 3 by 4 comma 1 by 4. And in the above, we have calculated exactly this value and exactly this value, which is nothing but pi by under root 2. So this is the glimpse of beta and gamma function. And the last, maybe this will be the last one, that trace the polar curve r square is equal to a square cos 2 theta. So before doing that, we have discussed one thing here, that is we wrote that mod of sin x, oh sorry, sin x is less than equal to x. So I want to emphasize here, clearly you can see that this x is greater than this sin x, and when this is for x positive region. When you talk about x negative region, x is less than equal to sin x. So overall we can say that, like if we take mod on both sides, this inequality will change and this inequality will remain same. So we can write it as this all. Okay. In general, for x belongs to R. So now trace this particular polar curve, that how we can start. Try this first, then we'll discuss it here. Just give me 2 minutes only. You try it. Did anyone got any answer for this? Or how to approach this particular one? So we need to first check the symmetry of the curve. So along theta equal to 0. So how one can check the symmetry of this particular curve along theta equal to 0? Anyone? To check the symmetry at theta equal to 0, we have to replace this theta by minus theta and see whether the curve remains same or different. So this will be a square cos of minus 2 theta, which will be a square cos of 2 theta. So it is same. So that means our curve is symmetric about theta equal to 0. Now along theta equal to pi by 2. So for that we have to replace theta by pi by 4 minus theta. So for that a square cos of 2 times of pi by 4 minus theta. So this will give us a square cos of pi by 2 minus 2 theta, which will change this into sine square 2 theta, which is not a square cos 2 theta. So what we can conclude from here? We can conclude that our polar curve has changing, so it does not have symmetry about theta equal to pi by 2. Now in the next we can check along theta equal to pi. So how we can check along theta equal to pi? Tell me. For theta equal to pi, what we have to replace? Sorry, here we have one mistake, that for theta equal to pi by 2, we have to replace it 2 times of this, that is pi minus theta. So this will be 2 pi minus 2 theta, and this will be again cos square 2 theta. So this is symmetric about theta equal to pi by 2. Now the left thing is that what about theta equal to pi? So for that again we have to replace it with respect to which one? Tell me. Or do we need to check with respect to pi? Since we are getting theta equal to 0 asymmetry, theta equal to pi by 2 of asymmetry. If we have a curve of symmetry like this here, so it can be drawn like this. If it has symmetry like theta equal to pi by 2, so it will draw like this. And again, we can check theta equal to 3 pi by 2, or we can, one more thing we can check, pole. And this is our pole. So to check at pole, what we will do, we will replace r by minus r. So pole, at pole we are checking. So minus, it will give us minus r whole square is equal to a square cos times of 2 theta. So this will be r square a square 2 theta. Same curve, that means our, that means the given polar curve is symmetric about theta equal to 0, pi by 2 and pole. Okay, so what we have left? What is the next task? Next task is about the slope. In the class, we have learned that we have to check where this dr by d theta is going to 0. Here we have to write dy by dx. Since we are talking about tangent, dy by dx is going to 0. We need to check this kind of um, tangents. So dy by dx in the given formula, dy by dx is nothing but f theta sin theta plus f of theta into cos theta divided by f theta into cos theta minus f theta into sin theta. This either we have to check this for the slope of tangent, and for simplicity what we check 0 comma theta naught, what is our tangents. So for 0 comma theta naught, a square cos 2 theta will be equal to 0 square. This will give us cos 2 theta equal to 0. Then in between 0 to 2 pi we are discussing, this will be pi by 2 or 3 pi by 2. So this will give us pi by 4 and 3 pi. Just a second, please. Sorry for that. So we have two tangents. Here theta equal to pi by 4 and theta equal to 3 pi by 4. This r will be, sorry, not tangent. This r will be 0 and this pi by 4 and 3 pi by 4. And rest we can check where our polar curve does not, we need to draw. So since we have given that r square is equal to a square cos 2 theta. So we will take the benefit of this r square. We know that r square is always greater than equal to 0. Therefore, we can conclude that this cannot be negative. So we are assuming that this is negative, then we will see the region, or we will decide the region of for theta for which we does not need to draw this particular curve. Cos 2 theta is negative. Since a square is a non-negative quantity, we can say that. Now our cost region will negative in this particular one and in this particular one. Okay, so 2 theta must be belongs to this pi to 3 pi by 2, or I have done something wrong. In which quadrant cos is positive? Anyone? In which quadrant cos is positive? Second one or third one? Second or third or second or fourth? It is correct. So it should be in this particular one. And since it is 2 times of theta, so it is going to be half. So we have to consider the next round also. That is 3 pi to 5 pi by 2, we can say. So here it is pi by 2, 3 pi by 2 to 5 pi by 2 also. So we can add also like 5 pi by 2 to 7 pi by 2 because that is 2 theta. So we have to consider the values between 0 to 4 pi. So it is going to be half. So theta will be pi by 4 to 3 pi by 4 union 5 pi by 4 to 7 pi by 4. So our region should not be belong to this, or we don't need to draw in this particular region. So I'm again emphasizing here that why I am taking from 0 to 2 pi, because our theta, if we talk about theta only, then we can think about 0 to 2 pi. Since here our 2 theta is there, so we talk about 0 to 4 pi. Suppose here we have some theta by 2 type terms, then we will talk about 0 to pi type interval, because it will again give us 0 to 2. So this is just for your sake of simplification or no confusion. So we know that our curve is symmetric about theta 0, pi by 2 and pole. And what the other thing we know, that we know that our curve will be 0 at theta equal to pi by 4 and theta equal to 3 pi by 4. And the other thing is that we know that we should not draw the region where theta belongs to this. So I can write it here, not should not draw for value of theta. Okay. Now we know where we have not to draw. Now, what is the left thing? The left thing is that, and it also, we will also call it as in terms of the lecture, pole, that we are checking pole, where the pole lies. So, in the last thing, what we have to do, we have to think about the range of this curve. To calculate the range of this curve, we need to just draw some value. We will put the value of theta and we will get the values of r. So this is a square cos 2 theta. Again, I'm saying since it is 2 theta, we have to think about until 4 pi something else. So at theta equal to 0, cos 0 is 1. This is a square, and we know that r is always positive. So this will give us a. Now, please keep this in mind that we cannot go into this region. So that means we cannot talk about pi by 2. Oh, okay. And we know that at pi by 4, it is 0 already from this pole. I made a mistake. This is polar. This is our pole type thing. 0, when we put 0 and we calculating the value of theta where the pole lies. So what we can do next, we can talk about pi. Again, a square cos 2 theta will be a square. This will give a. For simplicity, if I let you know that what happened when pi by, we will put pi by 2. So it will give us cos square, a square cos pi. So this will give us minus a square, and r square is cannot be a minus square. So we can say it does not exist here. Okay. What is the next value we can think about? Can we think about 3 pi by 2? Again, no. At 3 pi by 2, a square cos 3 pi. That is again pi plus 2 pi. Means this is pi, and again taking round is 3 pi. So again this does not exist. Okay. Now we can talk about 2 pi. At 2 pi, this will become cos square 4 pi. So what will be the value of this? A. Or here we can make a less stable because of this 2 theta. While deciding the region, we have to take the region 2 times, and while deciding this table, we can also think about only 0 to pi, or because it will give 0 to, it will cover at 0. If we will take theta 0 to 2 pi, then 2 theta will cover 0 to 2 pi range. Now we know that our curve is symmetric about theta equal to 0, theta equal to pi by 2, and pole. And we also know that where the pole lies, and we also know that where we have not to draw the region. So let us first mention, then we will draw the curve. Theta equal to 3 pi by 2, and this is again theta equal to 2 pi. So our curve, where the curve is not like pi by 4, 3 pi by 4. In between this region, our curve will not lie. So I'm drawing here. This is, let me draw with some red line so that we can get that we have not drawn under this. So this is theta pi by 4, and let me draw it here. So this is theta 3 pi by 4. So this is the approximate curve. If there would be some mistake, I hope you will get to know. This is 7, this is 5 pi by 4, and continuation of this will give us 7 pi by 4. So we don't need to draw here in this region. Okay, just we need to talk about this one and this one. And we know that it is symmetric about 0. So first of all, we will draw from here. At 0, it will give us value a, and it will go, when we'll talk about this pi by 2, it is theta equal to pi by 4, it will goes to 0. Why? We have this pole lies on theta equal to pi by 4 and 3 pi by 4. So it will go to like this. It will go to this. Okay, it is started from A, it has gone to this one at pi by 4. And we know that it is about theta, symmetric about theta equal to 0. What we can draw? We can draw like this. Okay. Now the next line is it is symmetric about theta equal to pi by 2. So for theta equal to pi by 2, it will be like this. Since we are talking about terms of r, so it will be again positive a. Now it is also symmetric about this pole, and since it is symmetric about the pole, it will be like this. Okay, so this will be our figure of r square. Let me r square equal to a square cos 2 theta. So this is the last question of the today's session. Let me just, I'm again saying this is a rough diagram. Don't think that it has been drawn in a wrong way. So this will be like this. These all 4 petals are symmetric. Okay. So that's all for today. If you have any doubt, you can ask. Otherwise, let's end today's session. Okay then. Bye. Okay then. Let's meet you on Tuesday on regular lecture of this multivariable calculus.